Good morning, everybody. First, I would like to express my gratitude to the organizers for their hard work and their effort to organize this international event on medical education. I am so grateful to work to talk about artificial intelligence and medical education challenges of generative precise results in narrative medicine development. Here, the outline of my presentation, which I will address some idea, some flowing idea. After introduction, discuss. I give some definition for generative pre-trained transformers. I talk about the medicine narrative and large clinical language models, I mean here GPT applied to medicine using natural language processing. And I'll discuss also the role of GPT-4 in medicine education and the limitation of these models in clinical narrative or the narrative clinic. And I conclude by some perspectives. So, there is an increasing interest in developing artificial intelligence systems to try and interpret various existing data in order to create unique and personalized content from that learned knowledge using different algorithms and tools as artificial intelligence-powered generators and solutions aim to enhance applications and services including various clinical practice, augmented medicine, medication management, medical education, and electronic health records, clinical narrative diagnosis, and so on. The data available in electronic health records became the best way to clinical narrative prediction that covers an exhaustive study of a highly technical experience of medicine, including direct observations, diagnosis, as well as treatment and management of real-life patients. I mention here the mid-GPT as a transformer model able to extract and predict medical concepts, mainly named entities, ontology, Western engineering, sentiment analysis, semantic analysis, etc., using NLP inference to process unstructured clinical text, biomedical codes, patient record, context, occurrence, concepts, etc., then to create a sequence of pathology for each patient, for instance, that could be data traded for mid-GPT system. So what are generative pre-trained transformers? Generative pre-trained transformers are multimodal large language model developed by OpenAI and are interactive system called chatbots. We know that chatbot is machine programming and that automates question and answering, simulating from human natural language. GPT is a type of large language models that use deep learning to produce natural text based on a given input. We talk about massive amounts of text data, the million or the billion initiator of text, and the GPT creator, generator of information from data sets. A list here, the palm, the bird, GPT, other, like for instance the med system as mentioned above. GPT can process a wide range of text, paragraphs, quotes, creative writing, and provide psychoanalysis, and even summarizes based on inputs given. I talk also about GPT parameters as complex models. So the number of parameters in the model determine how complex the model will be and how the amount of information it can be processed and stored. The more sophisticated GPT models fueled from artificial intelligence application that's just mentioned with Professor, are the more computationally expensive, and it is to try and to use. Transformers type of deep learning uses natural language processing tasks merged in various applications, translation, post-engineering, summarization, etc. I go quickly because of the time. What does natural language processing use in this process in large language models, as we mentioned? The large language models and large clinical language models are a field of computational linguistics and framework introduced by artificial intelligence as interactive protocols to understand and generate text using natural language processing and using natural language inference and also assess semantic textual similarity, recognize clinical concepts and medical relations, medical question and so on. So, large language models and GPT have several potential use for medical education, including generating education context, translation medical education materials, creating virtual patient simulation, providing virtual tutoring. GPT can help professors create engaging and effective learning materials and can generate virtual patient scenario to help medical students practice their diagnostic and treatment skills to learn medical concepts in a language they are not proficient in. Opportunity for students who need extra help, such as virtual tutoring, and are the form that can be served for educator, more detailed feedback for the students. What would be the role of GPT, generated transformers, in narrative medicine? So we ask about what would be the role of GPT in narrative medicine in particular. As doctors, as professors of medicine, it has been a privilege to work with patients and listen to their stories. All the stories we present are taken from true direct narrative, meaning natural narrative from a patient discourse. Resonate strongly with experiences in professional practice, listening to the patient's voices and their authentic experience has become central to narrative medicine on the voice. We optimistically focus on the position sites of GPT models will have clinical language models because these models seem similar to text writing by human and capable for understanding context and generating responses that are appropriate to the conversation. One of the many fields of GPT can be applied to generate medicine text, and so There are many applications that can be used by GPT models. Here as you see in this slide, mid-GPT prediction and inference. That's the main objective of the GPT is to generate predictions that make decision making for professors, also for students. Model phenomena, and to model means to model phenomena, other experiences, other expertise, and process the tokenized structures into sequence of tokens, words, subwords that the system can understand. The model process to tokenize input through each layer. We talk about convolutional neural network supported by deep learning used as algorithm in artificial intelligence to get the best performance. Fine-tuning of the model is required for specific tasks on domain, specifically, for instance, education. But although these advantages, there are many challenges and limitations of GPT, of generative pretrained transformers in clinical narrative and diagnosis in particular. Because GPT has a certain weakness that are enabled to understand complex context, to its reliance on gated data. GPT ground on internet text, which can generate nonsensical and inappropriate, inaccurate, or irrelevant responses to certain situations. The models are limited compared to text of humans that cannot process complex emotional situations and cannot understand sacral, for instance, humor and human communication in general. And GPT has a true generation from structured content, only for structured content. I mean there multiple expressions, for instance, some expressions compound word named entities, medical named entities, medical concepts, and narrative structures due to other electronic resources, like, for instance, humor or things like that, to be processed by this GPT and generator. Due to grammatical issue, errors, for instance, that needs fine-tuning, that needs proofreading, for instance. GPT are not able to access all the knowledge that humans have. The models in progress, of course, so they are limits on the number of requests and size of input, as well as cost involved in computational power. Over-generated, we have in GPT some over-generated content without any precision. Privacy and compliance with international laws in general, and ethical questions that should be discussed. To get the best performance, free tuning of the model these models are required for specific tasks and set of data or domain that need resources in intensive and time-consuming. Of course, this limitation are merely for clinical narrative methods. I mentioned here paper published by Clovis Mariano Fagion in 2017 about MedGPT, medical concept prediction from clinical narratives, that some correct identifying some correct diagnoses are part of response of 64% of cases, that only the 39% cases give correct diagnosis. That means that electronic health records and electronic resources are not available with medicine narrative data, because of each record contain identifying information that must be standardized, as mentioned Professor after. Those transmission is protected by health insurance portability and accountability, and some requests not with by the public until now. Some perspectives that can leverage and optimize this kind of GPT transformers, although GPT used as an assistance tool in medical education, mainly narrative clinic or clinic narrative, research and clinic narrative. However, it cannot be considered as a replacement for human capability, human ability, and knowledge. Not only information, but also what we call basic knowledge-based systems used by artificial intelligence and other supported other methods and algorithms, like, for instance, like deep learning, machine learning, neuronal network, etc., as it is flagged by the limitation that artificial intelligence faces. However, medical professionals can leverage GPT to automatically summarize key details such as symbols, for instance, emoji, for instance, as semiotic analyzer, for instance, for to establish the relationship of dialogue between machine and patient, or machine and doctor, also to give further information about diagnosis and treatment, as well as extract relevant information, relevant facts, and other knowledge from patient records, such as laboratory research, for instance, or imaging reports, assistant tool in medical education, electronic resources, and medical narrative. So, large language models, mainly large clinical large models, using natural language processing here as a tool, as a technique, fueled from supported by artificial intelligence models, personalized interactions, continuous learning, and improvement of language expensive content creators that can generate different from very dynamic. I talk about dynamic systems that can generate on the time and with using, for instance, an expensive, massive media or big data to analyze and to process various contexts. And finally, large language models, large clinical language models mainly, banks on existing large language models through active training data using supervised learning and natural language algorithm. And so, thank you very much for your attention.